Evaluating exponential models. The population of India was about 1.25 billion in the year 2013, with an annual growth rate of 1.2%. Write an exponential function p of t that models the population of India, where t is the number of years since 2013. Use your predict function to predict the population, when the population of India will be in 2021, and when will the population of India reach 2.5 billion. All right, so let's go ahead and get started. So an exponential function, just as a reminder from our last section, looks like this. So we'll call this function p of t. So p of t is equal to a b to the x, where a is your initial amount, b is your growth rate. And since our input variable is a t, we'll use a t here. Okay, so in this problem, we were given a starting point of the year 2013. And this was how many people? 1.25 billion in that year. So we're going to use 1.25 as our initial amount. And here we have a growth rate of 1.2%, which means in the following year, the population would be 100%, all the people that were there previously, plus 1.2% more. Or in other words, it would be 101.2% would be the total number of people in the country. So that would be a B of 1.012. So 100% plus 1.2% more. So using that information, we can go ahead and make the formula. So the population would be equal to our initial amount, 1.25, and the units is in billions. Our growth rate is 1.012, 100% plus 1.2% more, to the t power. Use your function to predict what the population of India will be in the year 2021. So again, we have to be mindful of when time started in this function. Time started in the year 2013. So 2021 would be 8 years later. So to answer that question, we simply take our function, p of t is equal to 1.25 times 1.012, and for time, we'll substitute 8. So if we do that, 1.25 times 1.012 raised to the 8th power, we get an answer of 1.375 billion people. When will the population of India reach 2.5 billion? So we want the final population to be 2.5 billion. Now we can set up that equation quite easily. 2.25 is equal to 1.25 times 1.012 to the t power. And what we're looking for is what's t? When will that happen? In our class so far, we haven't discussed how to solve this kind of equation. We haven't discussed how to solve an equation where the unknown, where the variable, is in the exponent. And that's what this chapter is all about. This chapter is all about leading up to being able to solve this type of equation. So question C, we don't know how to answer that yet, but we will in a few days. Here's one for you to try. It's just like this last one. I'll get you started. The population of China was 1.39 billion in 2013, with an annual growth rate of 0.6%. Write an exponential function that models the population of China, where t equals the number of years since 2013. And then predict the population of China in the year 2021. So an exponential function, p of t, is equal to a b to the x. A is our initial value. So we were told a starting point of 2013 and an amount of 1.39 billion. So 1.39 billion is our initial amount. and we're going to use that for the variable a. And then you have to fill in a value for b. So if the growth rate is 0.6%, there will be 100% in the following year, plus an additional 0.6%, or in other words, 100.6%, which you can then change into a decimal in order to get your value for b. So why don't you go ahead and do that? Find your initial value, find your growth rate, create the function, and then use your function to predict the population of China in the year 2021. All right, so I'm going to go ahead and show you the solution, which hopefully you did find. P of t is equal to our initial amount, 1.39. Our base will be 1.006 raised to the t power. So that's our function. To answer question B, the year 2021, if time starts in the year 2013, this would be 8 years later. So to answer question B, you have P of t is equal to 1.39 times 1.006 to the 8th power. So 1.39 times 1.006 raised to the 8th power would be 1.458. And again, the units are in billions of people.